Hello everyone, I'm in class with some of my students and we are starting this example on our track and field day data. So we've already gone through this, the first part of these note sheets. We talked about how we can use R to describe a linear relationship, and R is a number that helps us describe that linear relationship. Then we went through and practiced how to estimate R just by looking at the scatter plot. Then we talked about properties of R. And in that, talking about properties of R, we had this example that we looked at where we were looking at sprint time against long jump time. And we changed the units and we flipped the axes. Well, this data on the problem that we're doing now is that same data. So you need to enter in this data to your calculator, and then once you have that done, come back to the video. So pause the video, enter in the data, and then come back and we'll solve this problem together. Are you guys ready? Yeah? Okay. So this is the scatter plot of this data. So if you wanted to plot it by doing y equals and selecting your scatter plot, you would see that it looks like this. So determine the correlation coefficient R using your calculator. So you're going to do stat, calc, change your list if you need to, and find R. Were you guys able to do that? Did you already do that? What'd you guys get? Let me get my notebook to double check you. If you didn't get it yet, be doing it while I'm double checking. I got negative 0.84. Did I do something wrong? You guys got 0.84 negative?
Is that after round?
I think so. I don't have my data entered, so I'm relying on you guys. Is that rounding correct? Yeah. Okay. You could go to 3 decimal places too if you wanted to. I usually just go to 2, but you could go to 3. Okay, so part of your can you do is going to be interpreting the correlation coefficient. And as we go through this, I hope that you notice that this is exactly the same as what you just did on your Can You Do 41. So there is a strong negative linear association between sprint time and long jump distance. In general, as sprint time increases, long jump distance also increases. So we know that there's some relationship. We don't know if it's the sprint time causing the long jump situation. I bet you it's something to do with their training, like the muscles that you use, the body muscle memory that you use for a sprint is different than what you use for a long jump, and they don't lend well to each other. You know what I'm saying? Maybe. Yeah. I don't know. But there's obviously a relationship. Is the long jump where you run and then they like swing their arms and land? What's the pole? Pole vault? I would think the same thing, Maddie. I would think that they would lend well. Mia? Yes. Yes. Yeah. In fact, that maybe is a better way to think about it. Maybe we should, if you're struggling with that idea of causation, think about it as more of a coincidence. Is this a coincidence, or is it a real relationship, or is it causation? It could be, but we don't know that from R. That's not what R tells us. Oh, yeah. Thank you. Thank you, Hunter. That last word should be decreases. Good thing you guys were here and I wasn't just filming this on my own. Okay, so the one thing that I need to highlight for you guys is that there is one slight difference between today's phrase to memorize and last time, and that is the word linear. Last time, we didn't know for sure that it would be linear. Our options were nonlinear, curved, or linear. Today, it's always linear. You only use R when there is a linear relationship. Are you okay there? Okay. C, what effect does the red point have on the correlation? Well, we don't have color, so I made the dot ginormous. So what effect will this guy have on the correlation? What do you guys think? Strengthen or weaken? Weaken. And actually, I know the R value of this data without that point because that's this data. Notice I did not include the outlier on this data, knowing that we were going to do this problem. Without that outlier, your correlation is -869. What correlation did we find? -8.4. So it does weaken the relationship. Not by a ton, but part of that's because look how close he is to that point. Like he's out of the pattern, but he's not like way out. So the red point weakens the correlation because it is outside the linear pattern. Is it correct to say that your R is -0.84 meters per second? No bueno. No. Exclamation. Okay, I'm back. I ran out of space right after we did. I ran out of space on my laptop to store the video, so it stopped recording right after we did D, I think. So now we're on E as an echo. What happens to R if we change sprint time to minutes and long jump to feet? So hopefully you're saying to your computer screen, nothing. So I gave you an example of this. On this page, I changed it from inches to centimeters, and we know that has no effect on the correlation. So even if you changed both of your variables, it would not change your R value. What would happen to R if we switched the X and Y axes? Are you yelling nothing? I hope so. Hope your parents are like, what are you yelling about? So I did that here at the top of your properties of correlation. Would we be able to use R to determine the strength of the data if the pattern in the scatter plot was curved? No, because R only applies to linear data sets. Last, can we conclude that longer sprint times cause long distance runners to have shorter long jumps? No. Causation is a very strong statement in statistics, and you have to have more evidence than just an R value to prove causation. We know that there's a relationship. We don't know, and we cannot use R to say one causes the other. So you are definitely ready to do your can you do at this point. However, if you are a distance learner or you had me during an A day, you need a little bit extra before you go to do it. And the little bit extra is this. On this properties of correlation page, I should have added in that we only have correlation if two variables are quantitative. I didn't add it in because I assumed that we were all working from that knowledge. And the reason I assumed that is because this whole unit is on investigating the relationship between two quantitative variables. We've already talked about how to do this for categorical data. So this entire unit, everything is the relationship between two quantitative variables. I spelled quantitative wrong here. That's a sad day. So I assumed that once we got to this page, there was an already understanding, an underlying understanding that this only works for quantitative data. So you'll have one or two questions in your can you do where you need to know that. You need to know that in addition to these properties, you only have an R value if you're dealing with two quantitative data sets or two quantitative variables and they have a linear relationship or association. Okay, that's it.